Another way we like to talk about demand is we like to express demand as a linear function. This is something that is only applicable to HL students, so if you're an SL student, probably not something for you. However, I think for everybody, it is a good way to kind of conceptualize demand and the demand curve that we create from this. So the demand function is just like any function you would do in a math class. We change it, of course, a little bit. We say instead of y equals mx plus b, for example, we say instead for demand that its QD is equal to a minus bp. And what this is really getting at is that what we chart on our x-axis, quantity demanded, is a result of what we see or the changes that we make on our y-axis, which is price. In this case, A and B, they're just variables that we're going to change or that will be different depending on the demand curve that we're looking at. Now keep in mind, we said this once already, but maybe you've forgotten, in economics, we actually put our independent variable, the variable that we make changes to, price, we put it on the y-axis. So that's a little bit different than they might do in a math or science class, but it is the form that we follow in economics. Well, to understand this formula better, we need to learn or talk about specifically the A variable that we see right here. Now in a standard one, so this is an example that we'll work through in a minute, the A variable will be given to you. The point is that number, it really could be anything. Likewise, the B variable, in this case 5, that could be anything based on the demand curve that you're trying to show. So let's talk specifically about A. It's called A, it's convenient because it's also known as the autonomous level of demand. And what we mean with the autonomous level is, it's how much demand would exist even if there were no price to pay, so even if it were free. And that might seem a little bit confusing because wouldn't you want an unlimited amount if it were free? We'll come back to that in a moment. It will always be a positive number. The autonomous level of demand, it can't be zero and it can't be negative. If demand for a product is zero, well then there is no demand for the product, so we don't talk about it. And you can't have negative demand for a product, so it has to be positive. Another feature of the A variable is that it will also always be the x-intercept when you graph it. So I can prove that real quickly to you here. We're going to take this same example and look at it two different ways. If price is zero, remember we're saying that the quantity demanded results from a certain price. So if the price is zero and I go ahead and solve this, well, -5 times 0 equals 0. So 50 minus 0 equals 50. So quantity demanded, the x-intercept, when the y value is 0, the x-intercept is 0. Okay? Well, that doesn't change no matter what happens over here. So if instead of it being 50 minus 5p, it's 50 minus 2p or 200p or whatever, as long as p is 0, the x-intercept is always going to be 50. So that's a good hint to use whenever you're going to graph these, and whenever you're given this, you're probably going to have to graph it. So when you graph it, you can just real quickly take the A variable, whatever it is, again in this case 50, and just put it straight onto the x-axis as one of the points that you graph. Okay, let's get back to this autonomous level of demand idea. The reason that demand isn't going to be any higher than, in this case, 50, so no more than 50 will be demanded, and the reason that's true, and that might seem confusing, because didn't we say that there's unlimited wants or infinite wants? Well, that's in a bigger sense. There's unlimited wants for stuff. But when we look at one particular thing in a particular market over a particular time, so this might be, pizza in a neighborhood in one day. Well, there's not an unlimited or infinite amount of pizza demanded by any group of, say, 10 people in one day. There's only so much they can eat. Well, that relates back to what we saw in the previous video, or a previous video, which is the law of diminishing marginal utility. We don't want infinite amounts of anything in one time period, okay? So that's our justification for that. All right, well, let's talk then about the B variable. That was the A variable. Now we're going to talk about the B variable. We're always going to see it as the coefficient of P, so it's going to be right next to it. It essentially is telling us the slope of the demand curve that we're going to graph. Now here it's a little bit tricky. Remember, In economics, we switch which axis the independent variable is on. Therefore, instead of it being rise over run, it's going to be run over rise. So, in this case, you can see this as -5 run over 1 rise. So what that's saying is, how much does QD, which is the run on the x-axis, change for every 1? We never actually put anything there, but it's always over 1, for every 1 change in price, which is the rise on the y-axis. Okay? For demand, this is always going to be negative. That correlates to what we talked about previously, that the demand curve always has a negative slope. Okay, so the next step, once we know all that, is we want to take this and we want to solve it and put it into, remember, this is called a price schedule. So in this case, all we're going to do is we're going to start with the lowest price possible, 0, and graph it out from there. So remember we said if we take 0 and plug it in for P, it's going to be 50 minus 5 times 0, which is 0. So 50 minus 0 is, of course, 50. Okay? Now if we raise the price by 1, we expect demand to fall. That's just the law of demand. How much is it going to fall by? It's going to fall by the value of that coefficient. Let's go ahead and prove it mathematically though. So if we do 50 minus 5, plug in the price 1, that's 5 times 1 is still 5. So 50 minus 5 is 45. What if we raise the price to 2? Well, again, we would expect it to fall by another 5. Let's prove it mathematically one more time. 50 minus 5 times 2, 5 times 2 is 10, so 50 minus 10 is 40. Now clearly we see a pattern developing. So you don't need to calculate all the way through here. We can clearly see that as we continue to go up by 1, that the quantity demanded will continue to fall by 5, again, the coefficient of P. And we'll do that until the quantity demanded is 0. So what we're saying here, this one is going to be our y-intercept, or our price intercept. We're saying at this price of 10, no one will demand this product whatsoever. Quantity demanded has fallen to 0. This can be a bit tricky, so let's do a little practice. Okay, I'm going to take you through a few examples of taking a demand function and turning it into a demand curve. It's a really simple process. You will want to make sure that you're following along on the OneNote. So pay attention to where we are. We're inside of the micro section, and then over to the right, it's a few pages down where it says QD equals 20. So get yourself there, and we'll get started, and here we go. Okay, as we already saw, we can make a demand schedule that has all the prices from where price is 0 all the way down to where quantity demanded is 0. And all we simply need to do now is put these points in and then go ahead and just connect them with a line. So we can always start, the first thing that we always want to do is right here, it's already done for you, is whatever the a variable is, we can just go put that directly onto the x-axis. Remember, it's the x-intercept, so we don't even really have to think about it. We can just put it in. Likewise, if we've calculated this whole table, which we don't always have to do, but we already have done it, we can just go to the other intercept, which is 0 and 10 here, and this is going to be your y-intercept, where quantity demanded is 0, but price is some positive number. So again, here, this is going to be 10 right there. From there, we're just going to go, according to the formula, every time we go down 1 in price, we lose 5 in quantity, or every time price goes up 1, we lose 5 in quantity. So if these are each increments of 1, and they are, and if these going across the x-axis are increments of 5, the formula here is saying every time I change the price by 1 or increase the price by 1, I lose 5. So we're going to go from 50, we're going to go up 1 and over 5, which is just 1 to the next corner. Okay? And remember, that confirms what we said. 50 minus 5 times the price of 1 is 45. Well, what if the price is 2? Well, then we go up 1 and over 5, so again, we're here. And obviously, that pattern's going to continue until we get to where the price is so high, 10,
that none are demanded. Now we'll want to connect these dots. This is why you learned how to do connect the dots back in grade school. And with this type of task, you do need to be very careful to be very exact. So even here, where I can tell the bottom of my line is not quite at the intersection where it's supposed to be, I'm going to go correct that and make sure that it's absolutely perfect. We need to label this, and we're just going to call it D. You don't. I see a lot of people do this. They'll call the line QD equals 50 minus 5P. Okay? You don't need to do that in economics, and please don't. Just call it D. It's the demand curve, and that's what we're looking at there. Okay, over here to the right, we're looking at another problem, QD equals 200 minus 2P, and let's go ahead and see if we can't figure this one out. You see here, I've given you only a couple of spaces to make the schedule with. So we can always start with the a-intercept or the x-intercept, the a variable, and we know that that means when price is 0, x, then y, then quantity demanded is going to be 200. That's what the a variable is. Well, if it's a straight line, and it's always going to be a straight line until you get to university, we only need one other point. So what we make that doesn't really matter because it's going to be a straight line. So let's do 10. So price of 10, 200 minus 2 times 10 is 200 minus 20. So this is going to be 180. So our first point is going to be here. And our second point is going to be like this. Again, we can just draw a line the rest of the way. It's going to be a straight line, so we can draw it all the way to the other axis. So this one ended up being a 45-degree line too, just like our first example. But, of course, because it's labeled differently from 0 to 200 as opposed to 0 to 50, it is actually, of course, a different line or different curve. If we want to double check that we did everything right, we could take a different price here. We could take 20. Let's go look at 20 and confirm that that right there is 160, and it is. Or we could do that a different way. What if the price is 50? That means the quantity demanded should be 100. Well, let's see if that works in our formula. And we see, of course, that it does. So when the price was 50, the quantity demanded was 100. Okay, there are three more examples on this page that I'd like you to go ahead and do. I'm not going to talk my way through them. I'm just going to do them real quickly and show you the answers, and you can just confirm that you did it right. Okay, so you could have done it this way. That would have been perfectly acceptable, where you have price 14 equals quantity demanded of 0. That's fine. We see that up here. That's the y-intercept. Let's do one more. Let's see at price 4. We see that quantity demanded is 500. You could have also done this in another way. If you had scaled this going by 1s instead of by 2s, that's fine. There's not a problem with that. It's going to look different, but it's the same information. So again, we would take a price of 4. QD equals 700 minus 50 times 4, so 200. And that's, of course, going to be 500. So now, instead of 4 being down here where the 2 was, it's going to be right here. And of course, that's going to make the angle of our curve be a bit more steep. But it's not going to fundamentally change the information that the curve represents. Now, of course, also here we do have a bit of a problem in that we can't show the whole curve. So typically you want to try to show the whole curve, but sometimes they might give you a problem where they don't let you do that because they don't want to give you the simple way of doing it, which is just define the y-intercept. Next problem is over here. QD equals 140 minus 7p. Go ahead and do it on your own. I'll be right back. Okay, this one's set up a little bit weird, and the reason I did it was to show you the way I've done this is correct, but it is going to make it a little bit hard to use. If I need to know, okay, well, where's 19 on here? I haven't really given myself the room to say, okay, well, there's 19, and I'm just going to end up making a lot of mistakes that way. So the lesson out of this one is use your space. Okay, keep in mind there's no rules about how you have to scale the questions that you're doing. Okay, the last one for practice is here. And surprise, surprise, this one has the exact same look as the previous one. So the lesson here is pay attention to the numbers. And when you're presented with one of these, make sure that you're interpreting it correctly. If you have any questions or comments, leave them in the comments below.